So, first, the event will start with opening remarks by Professor Zakir from IIT Bombay. I request Professor Zakir to kindly deliver the opening remarks.
Thanks, Pratosh. On behalf of Grid Integration Lab, IIT Bombay, I welcome all the participants for this first webinar on this particular study, V2 study that we are conducting with the support of GIZ. And this webinar is, we are expecting to actually initiate a discussion around V2G capabilities with specific focus on heavy duty vehicles, the potential of heavy duty vehicles with respect to V2G support, and then how this V2G can potentially help the grid in different ways. So that's the broader aim. And this webinar will throw light on the technology of the V2G and the global status of readiness at, of V2G technology. And we'd also like to have some discussion on the readiness of Indian stakeholders on for V2G and potential of V2G in Indian context. So that's the broader aim of this particular webinar, but we'll have a few more webinars following up on the progress of this study as we move forward. With those short remarks, I again welcome. We have several renowned speakers lined up, as you can see in this webinar. And we have one interesting panel discussion also planned for this webinar that you will get to hear at a later stage. So with this brief remarks, I would hand over back to Pratosh for the next. Over to you, Pratosh.
Thank you, sir. Now I request Mr. Ashok Kumar Rajput to kindly deliver the keynote address. Mr. Ashok Kumar Rajput is a member, Power Systems, and ex officio Additional Secretary of Government of India, Central Electricity Authority, and has 36 years of distinguished service in power sector. Over to you, Mr. Rajput.
Good afternoon, everybody. I am A.K. Rajput. Professor Rathar has already introduced me. So I am basically an electrical engineer, having my BTech from Pantnagar and in 1985, and thereafter as a continuing study. So I did my MTech in power system from IIT Delhi. So I worked in NTPC as well as in most of the time in Central Electricity Authority. So generation, transmission, distribution, trading, the R&D and the renewable integration have been my areas of major work. And also, we in CEA started this electric vehicle, that is the e-mobility. So at each and every stage of e-mobility, I have been part of various assignments. So in that connection, now this today's focus of this particular webinar is, I'm not going to the fundamentals and how we started and what the existing system is going on. The concept is of vehicle to grid. Vehicle to grid means smart controls have to be there. That is the first requirement. And say it is basically energy and resource optimization. Whatsoever vehicles are there, they are the sources of storage. They have the moving storage, you can say. And when they are parked at a particular place, they becomes the, in a simplest term, the static or the stationary storage. So this feature of the vehicles and particularly of the high capacity batteries, say of the four-wheelers and heavy duty trucks and buses, that can be utilized to balance the grid. So we can attain the functionality of the grid flexibility. and also the management of the peak, the voltage and frequency supports. So these four parameters broadly will help in stabilization of the grid and better power quality of the to the consumers, as well as to the utility. The benefit to the utility will be that they can manage their peak demand and the energy requirement of the consumers with the help of these distributed resources. So it will come in the category of the distributed energy resources, where lot of flexibility exists when the power is available in excess from the renewable sources of energy. So these vehicles could be charged, and when the peak time is there, say particularly in the evening and when the grid is quite stressed, so there the expected relief can be obtained. Thing is that we have to devise certain control systems and the battery management systems commensurate to that. Maybe the metering system protocols have to be defined that how the commercial arrangements will take place. Insofar as energy is there, that mechanism is sure and foolproof. So this concept naturally will require some, say, at the beginning stage, some models we developed in some of the pockets and in different areas of the country, because every area of the country has the different geographical conditions and the climatic conditions, and also the availability of the renewable sources of energy. Of course, the conventional sources are widespread, and they are particularly in the form of the thermal, and also at a specific location in the form of the hydro. And now the pump storage plants are also coming to the rescue of the grid. So in this, what roles these our vehicles can play is more important, and it need to be studied further in detail. Today's this particular webinar and whatever this study has been focuses on these particular aspects. So it has been aimed in the study to carry out a comprehensive analysis of V2X. V2X means either vehicle to home, vehicle to grid, or vehicle to some other place, maybe some entertainment place or some malls, etc. Because the lot of vehicles get parked in the malls, and naturally at the time of the peak, when the peak charge is high and TOD is there, so there some concessional rates could be developed, which could be useful to the vehicle owners and also to the utility. So a bidirectional charging infrastructure is a must, that is a prime necessity for assessing the business viability of the V2G technology in the Indian context, or the same is true for any other country also. Once this model, I am hopeful, I am making some advanced statement. Once this model is successful in the Indian context, we can tell others, the other part of the globe, to adopt such type of the models with slight modifications as per their requirement. Because the sunshine and the winds, they are not continuous 24 by 7 in any part of the globe. So whatever is true to India and Indian geographies, that will also be true to the other parts of the world also. Thing is that whatever benefit of the study are there, they will be beforehand, and they could be modified, they could be further enhanced for maximizing the benefits. Electric buses and trucks will have the higher potential. Reason being, say, in case of the buses, there is a concept known as the depot charging. So right now it is one way of the charging from the grid, but this when the buses are not in service and they have been charged at a concessional tariff when the electricity was at a convenient charges, so that energy could be fed back into the grid. So this enhances the capability of the, you can say, the infrastructure as well as the assets. And when the feeding to the grid is at the local sources, naturally the line losses will reduce in any whatsoever is the segment involved, either it is of the transmission part or the distribution part. So that amount of losses in terms of the I square R and the transformer losses, that will reduce to a sizable level. So this study also places significant emphasis on business model for B2G applications, that what should be the business models. It will be analyzing the economic feasibility and what value streams are there. By value stream, we mean that what are the different models and potential review mechanisms for different stakeholders. That includes utilities, fleet operators, charge point operators, and EV owners. EV owners, just a writing remark I am giving, that EV owners should be given a double assurance that whatsoever they are doing and participating in this, it will require frequent charging and discharging. So the safety aspect have to be ensured and extra care need to be taken for the safety of the vehicles. When the two-way flow, when their vehicle battery and the battery of their vehicle is involved in two-way flow of the energy exchange. So we have to aim and to identify sustainable and scalable business strategies that can drive the adoption of B2G in India. I just give an idea that the cost of the housing assets, even housing assets or the commercial complexes, rising day by day, and people are investing quite heavily on getting a suitable accommodation, particularly in the areas which are being developed as a new. So those buildings also need to be developed, and if not there, the modifications in the designs need to be brought out, and that could be done at the, say, National Building Code is under formulation. It is at the draft stage. There we can give the suggestion because the building will be, say, for 60 years to 100 years. They are designed for that and last till that. So if something is to be provided for, say, which would be realized, say, after 10 years, then lot of R&M and this breaking and remodeling of will be required. So better to do it in advance. That may not be utilized by all at the same time, but it will be utilized in further. So we should have a futuristic approach in devising such things. So I am hopeful that the recommendations content will address the key challenges, such as one is the policy gap, what incentives are to be given to different stakeholders. It should be a win-win situation to each and every stakeholders. The readiness of the grid infrastructure and the role of the utilities, what the role utility will play in making the safe and secure supply, and also the protection mechanisms have to undergo a change when the two-way power flow is there, ensuring that B2G technology can be deployed efficiently and effectively in the Indian energy ecosystem. So we have to take into consideration one thing is missing, and maybe I've not gone through in much detail of this study. It will be that what are the expectation of the building owners or the flat owners or the asset owners, house owners, and what are the expectations of those owners of the building or the assets which will be having or acquiring the vehicles which are capable of performing B2G functions. They also need to be told, and automobile manufacturers also need to be told, that there is one-way charging that offers a certain lifetime of the battery and lifetime of the total assets. And another is the two-way type of the model, and will it be affecting to a larger extent or to a greater extent about the, you can say, the efficiency part of their total system and the life cycle of the battery. Will it degrade after a certain time if it is too frequently charged and discharged? And also we have to define the C rate also, the rate of charging and discharging in both ways. So that type of the controls we have to exercise. Thank you. I think as a part of the keynote address, this is from my side. I would like to listen to others.
Thank you, sir.
So I would like to listen and appreciate the views of others so that I also get equally benefited as the other participants are there. Thank you, sir. Thank you, Professor Athar, and thank you all other dignitaries and the participants for kind listening.
Thank you, Mr. Rajputji, for your enlightening keynote remarks on this very important topic. And we look forward to benefit from you further, including later on joining us in the panel discussion. Thank you very much. Over to you, Pratosh.
Thank you, sir. Now I would like to invite Ms. Laura Sustersik for introduction of the project. Ms. Laura Sustersik, Project Director, Support to the Ganga Rejuvenation SUID Cluster and Deputy Cluster Coordinator. Over to you, Ms. Laura.
Thank you, Pratosh. Good afternoon, everyone. It's a pleasure to be in this meeting, and I'm here in my position of Deputy Cluster Coordinator. So I'd really like to welcome participants, partners, and speakers on the name of the Cluster Coordinator, of course, Christian Kapfensteiner, on behalf of the GIZ and on behalf of the German Development Cooperation. So thanks a lot for being here to this absolutely forward-looking, innovative, and extremely timely webinar. We have heard from the keynote speech of Shri Rajputji how important is the topic we are looking into now. As India scales up to its electric mobility ambitions, it is important that we also look at innovative ways. So electric mobility, we have been discussing for a long time, but vehicle to grid is quite an exciting and new development. And will allow us to rethink the way we manage electricity. As we heard from the keynote speech, the idea of enabling electric vehicles to charge back the grid really would hold the potential to make the grid more stable and to improve the integration of the renewable energy. And also, and why not, it's always very important to unlock value streams across the energy and transport sectors. We all know that research is fantastic, but we still need the business models to bring the research into the reality of the world. And that having the capacity of looking at theoretical possibilities, experiencing, finding pilot projects, and then transforming them in real business opportunities for upscaling is essential. So today's event is part of our ongoing work under the Promoting Transformation to Sustainable and Climate-Friendly Electric Mobility Program of the GIZ. And through this cooperation, we aim to bring together, as I said, technical insight, policy perspective, stakeholders engagement, so that we can create together solutions that are future-oriented but very much grounded on the reality. So we heard from the keynote speech that the V2G study was conducted in collaboration with IIT Mumbai and explores the technical, economic, and policy dimensions of V2X as bidirectional charging, with a special focus on heavy-duty electric vehicles like buses and trucks as dynamic energy assets. So we have to address critical aspects such as grid integration challenges, battery degradation, infrastructure needs, we just heard in the keynote speech, and business viability from the perspective of multiple stakeholders. that are the utilities, the fleet operators, the CPOs, and the users especially. So it is really interesting that we can be here together, drawing lessons from the global best practices, at the same time grounding the insight in India's policy context and market realities. So that this study aims at offering a roadmap for scalable and inclusive V2G adoption. This also provides strategic recommendations that can inform both regulatory frameworks and investment decisions going forward. And I'd like to mention and link up to what Shri Rajputji mentioned earlier on the importance of testing these new technologies in the Indian context. We all know that India is promoting itself as voice of the global South. So developing solutions that are implementable in the Indian context with its absolute variety of climatic conditions, for example, from dry to rainy, from high mountains to coastal areas, is extremely relevant for the rest of the world and the rest of the global South normally, but also for the rest of the world, because the variety of situations that you have in India is so mind-boggling that it can really be upscaled and replicated in other parts of the world. And in this sense, I think it's a fantastic opportunity and fantastic work you're doing here. So I'd like to express appreciation to Professor 𝐕𝐞𝐡𝐢𝐜𝐥𝐞 from the IIT Bombay for leading this study and all his colleagues involved in such technical depth and commitment. That is, thank you very much. From the GIZ point of view, your efforts, Mr. Zakir Hussain, and your team have been central in advancing our understanding of V2G and its relevance for India and for the rest of the world. I see also Mr. Björn Christensen is present here, and I'd like to salute him and thank him also for bringing global perspective and help us benchmark India's progress against international developments. And a special thank, of course, to Shri Rajputji that just delivered our keynote speech, member of the power system, and also the Central Electrical Authority. I think Central Electrical Authority is also present here for joining us today. And we are hopeful that the finding of the studies and today's discussion can contribute to ongoing efforts at CEA to shape enabling regulations, raise awareness on strategic potential of V2G for India's grid and e-mobility ecosystem and for the rest of the world. So I will leave you now with these few words to the capable hands and moderation of Professor Zakir Hussain, whom I thank again, and good deliberation. Thank you.
Thank you.
ma'am.
Thank you. Thank you, Ms. Laura, for your address and highlighting the need of the study and the expectation of the study. Thank you very much for your enlightening remarks, and we look forward for your cooperation going forward in this study. Thank you very much. Over to you, Pratosh.
Thank you, sir. Now, I would like to invite Professor Zakir Ratha from IIT Bombay for presentation on advancing vehicle-to-grid and vehicle-grid integration of heavy-duty vehicles. Over to you, sir.
Thank you, Pratosh. Let me share the slides here. Can you please let me know, Pratosh, if we can see the
Yes, sir. Yes, sir.
slides?
It is visible, sir.
Okay. So, very good evening, good afternoon, good morning, depending on where the participants are joining from. I once again welcome all the participants to this webinar on vehicle-to-grid study that is being conducted here. And this particular presentation that I'll be delivering is primarily focusing on the technology aspects of this vehicle-to-grid. As I mentioned earlier, with relatively some specified focus on heavy-duty vehicles, the potential of heavy-duty vehicles for V2G support. So I think the bigger picture is known to all of us. Why are we at the first of the day? First of all, why are we electrifying the transportation sector? So the reason we all know, there are climatic challenges, there are impacts and climatic issues that is impacting the entire world, and we in India are also already have started experiencing the impacts of this climate change, and therefore which highlights the pressing need to address these climate issues, which stems primarily from the emissions of the carbon and of course other NOx emissions, greenhouse gas emissions that are there. And that's why the transportation of electric transportation is happening with the assumption that the charging load is going to be catered from renewables, so that brings together the renewables and electric vehicles together, as we will discuss further in this presentation and the following presentations that are there lined up. So this slide, you can see the emissions coming from different sectors, and globally, as you can see, the power sector is the major contributor to these emissions, amounting for around 40% alone emissions that are coming from the power sector, and the remaining emissions are coming from other sectors. And as you can clearly see here, the next prominent sector that's contributing to the next highest emissions is transportation with around 21%. So now if you see the power sector plus this transportation sector together are contributing to around 60% of the total emissions. That's where the integration of these electric vehicles with the grid and the renewables and support from the potential support from the electric vehicles to the renewable energy uptake and vice versa becomes very, very relevant and important in this context. So that's the global overview. And coming to the country status that we have in terms of the overall emission breakup, here you can see the power sector is contributing to around 47% of the emissions, total emissions, and then we have the transportation contributing to around 11% of the emissions in the country. And now we look at the battery, how the battery electric vehicles. Of course, electric vehicles are broadly of four types, which includes hybrid vehicles, hybrid plug-in hybrid vehicles, and the fuel cell electric vehicles. But what is predominant one is that we are talking of here is battery electric vehicles. And as we know that it has been roughly around 30-35% of the capital cost of the electric vehicle is of the battery, and that's why the battery is at the forefront in terms of its prices. And as you can see here, the prices of battery, including cell and pack price, over a decade, from around a decade's time from 2013 to 23, has come down by around 1/5, to 1/5 of the prices that have been there in 2013, which is showing that there is a rapid fall in the prices of the battery. As a result of that, obviously, is making the electric vehicles relatively more competitive, more affordable alternative of the conventional vehicles. And this right side plot is showing the overall energy storage. If you aggregate this energy storage that these electric vehicles are offering, is in different segments. If you see here, freight trucks, it has gone quite a bit high, from 1 gigawatt hour to 50 gigawatt hour in 2023 compared to 2015. And then if you see 2-3-wheelers, that has gone from 2 gigawatt hour in 2015 to 80 gigawatt hour in 2023. Buses, 5 gigawatt to 130 gigawatt. And globally, if you see, the light duty vehicles are forming the major chunk of this total energy storage that they are offering to the for support that they could actually make. And in this context, we are talking of the grid support. So basic idea here is of this V2G is the battery that is purchased for the primary purpose of driving the vehicle is in most of the cases lying idle for a majority of the time in a given day. And if you look at the private vehicle, is almost 80% of the time they remain idle. So therefore, this asset of the battery, which is one of the costlier assets in the overall electric vehicles, remains unutilized for the vast majority of the time. And as a result, the question is, can we not make a better use of this otherwise idle asset that's lying there, that is already capital cost is already put up for the purpose of the driving of the vehicles. Now, once we have this battery lying under the vehicles, which remains unutilized for a reasonable time of a day, why we cannot talk about utilizing this battery storage? We know that we're not going into the here too much of the details of how electric vehicles or electrification of the transportation is stressing the grid. Grids have not been, particularly distribution systems, have not been designed to cater the EV charging load. So therefore, this is something new technology that is getting introduced into the grid, and as a result, that is impacting the distribution system in different ways. So some of them are listed here. We have done detailed study in the past on this impacts of electric vehicle integration on the distribution system, and you can see there are a lot of challenges associated with this. I can try to put up a simple example that I think can help us in understanding the potential impact that these electric vehicle charging load can actually introduce into the grid. Typical household in India is having the connected load of 3 kilowatt or 3 to 4 kilowatt. Now we're talking of a charger, home charger. Leave aside the public charger, public charging station charger. A home charger is typically right now of the capacity of 6 to 7 kilowatt. So a household which is having the connected load of 3 kilowatt, having a new charger, new additional load getting added to it of 6 kilowatt, that is almost now total kind of tripling the total load connected to a household. And then you just aggregate it at the distribution transformer level. You can imagine how much increase in the load is there on the distribution system. And this increased load has a lot of impacts on the distribution system. And this V2G promises not only to address those impacts that are already there, and some of the states in India are already experiencing in some of the feeders because of these high charging load in those feeders. And given the fact that we are at the early stage of adoption of electric vehicles, going forward at high penetration of electric vehicles, we'll have definitely a tough time in handling this significant EV charging load if it is not planned appropriately and the countermeasures are not in place, put appropriately. So this V2G is promising not only to impact these impacts of the charging load on the distribution system, but it is offering a lot of additional potential support to the grid. As I mentioned, this aggregate storage, if you see, is a lot of, and we are desperately in need of storage in general, energy storage for the RE-based EV system, RE-based grid, to address the intermittency, variability, and other grid stability issues in the system. And this mobility, sector is electric mobility sector is offering a lot of potential benefits from this storage. So this is giving us rough numbers, approximate figures of emissions coming out of each of the electricity generation generated in different parts of different regions of the country. As you can see here, we have roughly around 500 to 550 grams per unit of electricity generated in the northern region. Northern region in India is relatively better in terms of the emissions per unit of electricity generated, because we have quite a bit of number of states having Hydropower, we have relatively less number of thermal power plants compared to other regions. But broadly, you can see, at the national level, we have typically of around 700 to 750 gram of these carbon emissions per unit of electricity generated, which of course is indicating the need, which is already happening, is in the work in progress to address these emissions in the electricity sector through the renewables. And these are some of the examples of other countries. You can see here, France is having one of the lowest carbon emission per unit of electricity generated, which is primarily attributed to the nuclear power generation, a significant percentage of nuclear power generation that they have in the country, followed by Denmark, which is having 94 gigawatt per unit of electricity generated there, because Denmark is having roughly around 70% of electricity currently, electricity share coming from the renewables, that is reducing its emissions per unit of electricity generated. And then we have a few more countries, the numbers shown here in terms of the emissions coming out of the electricity sector. Now, while we are adding renewables and there are challenges to do with the renewables, this V2G is offering potential support to help in, more increased uptake of the renewables in the system, and eventually helping the taking the advantage of potentially this storage that is underlying in the electric vehicles. So, as I mentioned earlier, one of the main goal of electrifying transportation sector is to address the emissions from the transportation sector by charging these electric vehicles using renewables. So here you can see the renewables can help the electrification of the transportation, and electrification of the transportation and making better use of the V2G can actually help in better uptake of renewables through various support services that this storage can offer to the grid. And so therefore there's a kind of combined effort that is becoming significantly very promising if the two sectors are actually utilized in a way where we could actually make better use of the storage lying in these electric vehicles. So this vehicle to grid, as most of us are familiar with, is basically, here we are talking of pumping the electricity back from the battery of the electric vehicle in addition to charging the electric vehicle. And then we have different types of electric vehicle to grid, vehicle to V2X potential applications, where we talk of the vehicle to grid, vehicle to home, vehicle to building, vehicle to vehicle, vehicle to microgrid, vehicle to load. There are different applications that we could think of making use of this storage that is lying in the electric vehicles. So when it comes to technical side, as I mentioned, this presentation is primarily focused around the technical aspects of this V2G. We need, in terms of hardware requirement, we need the chargers that are capable of bidirectional flow of the power, which can take the power from the grid to charge vehicles and send power back to the grid. So the first and one of the first requirements is the charging infrastructure need to be V2G compatible. And then the most important, which is central, is actually the V2G compatible electric vehicles. So the electric vehicle should be actually, capable of providing the providing the bidirectional flow of the power between the grid or VSC and the vehicle. Not all electric vehicles are V2G compatible. As of now, we do not have hardly we have any electric vehicle in Indian market which is compatible V2G, officially compatible with V2G. But there are globally several other electric vehicles OEMs which are having the vehicle to grid compatible or V2X compatible rather electric vehicles. Some of the examples, of course, one of the early electric vehicles, Nissan Leaf, has been one of the early these models of V2X compatible, V2G compatible, and then a few more models that are available, many more actually, that are available globally, which are compatible with vehicle to grid functionalities. And then the other hardware requirement is the metering, because that becomes very important when we talk of the V2G. Of course, metering is even important for the unidirectional charging also, but when it's V2G, then separate metering in terms of depending on what type of mechanism in terms of the commercial regulations are there, so that metering has to be there. And then energy management system is another important aspect that is required, which also includes the communication system that's needed there. So we have been working on several pilots at IIT Bombay. This is one of the pilots that we are that's currently ongoing here for vehicle to grid and vehicle to home, where we have this electric vehicle. The period of this study is basically around 6 months, which is ongoing, initiated in December last year, and then it is expected to continue till May this year. And this is, you can see, this is we have a household here, and we have the grid supply, which is being supplying that building to in which this house is there. And then we have this electric vehicle in the parking lot of this building, and then there is a bidirectional charger that is offering this bidirectional power flow between the grid and home, and then between the vehicle and home, and the vehicle and grid. And this is a typical household which is housed in the campus for a residential building, and this is actually looking at the potential of this V2G in terms of the technological challenges and also the commercial viability that is there. And this is just sample data. Of course, later on we will have more data available to actually present the analysis of this particular pilot. So you can see here, this is 1 month data where we are looking at the this household consumption and the energy supplied by the EV and the energy drawn from the grid and other aspects, energy consumed in other aspects. So some of these results are actually shown here, where for on 1 month databases, what we actually have determined that the electricity bill has come down by around 25% for this, based on this 1 month data, by using this vehicle to home and vehicle to grid. And then we are also looking at different parameters. One of those parameters is the health of the battery, because this is very important aspect to see how the health of the battery is actually getting impacted by participating in these vehicle to X applications. So far, of course, the period is very short, 1 month here. We did not see any tangible impact on the health of the battery. You can see the health of the battery has been 93% throughout for this month of this observation. But of course, over a period of time, we will have more insights into if at all, how much, and if at all there is, and then how much is their impact on the health of the battery by participating in these different vehicle to home and vehicle to grid support services. So that is the hardware requirement that I was mentioning earlier. Then the communication requirement is another aspect where we are looking at this communication between EV and EVSE. There are some of the protocols that need to be there in this communication between EV and EVSE. We have communication between electric vehicle supply equipment and CPO, where we used to have earlier OCPP, which is now IEC 63584, and then IEC 63110 has been there. And then communication between charge point operator and utility discom, in this case, in our context in India, then there are the SON communication protocols that are there, and therefore the communication is very important in mass adoption of this vehicle to grid. And in terms of the current challenges associated with the V2G implementation, 𝐷𝐸𝐼 has been the compatible this V2G charging gun and protocol that has been there for a long time now. And these Nissan Leaf and other vehicles that I was mentioning earlier, most of the earlier vehicles, electric vehicles, were compatible with the 𝐷𝐸𝐼, but unfortunately, 𝐷𝐸𝐼 is actually more or less getting less and less share in the market because of the development that is happening in parallel with CCS. CCS is widely adopted, this protocol in this charging system, and it is being projected at CCS bidirectional would actually be more popular as we move forward. But the current status is that CCS bidirection is not as such commercially available, and there are some other challenges at the moment at hand. Interoperability are there the issues that you may have one EVSE manufacturer compatible with one of the OEM vehicle, and then that same charger may not be compatible with other OEM vehicles. So that interoperability issues are there. So this is right now in a transition phase where we see well-established 𝐕𝐞𝐡𝐢𝐜𝐥𝐞 charging protocol more or less getting less and less share in the market. And as a result, the industry demand is less, and naturally the manufacturing is not much there because there is no demand in 𝐕𝐞𝐡𝐢𝐜𝐥𝐞, because considering that the vehicles that are coming are more compatible with CCS, and then at the same time we are not having full-fledged commercially available CCS at this stage. Chargers available in the market which could be utilized for this V2G adoption. The other aspect is DC V2G and AC V2G. So DC V2G is basically when you have the DC charger outside, offboard charger, where you are converting AC into DC offboard and then directly supplying DC to the battery. There are high costs associated with the DC V2G charger, and there are standardization issues, as I mentioned earlier, also to some extent. Regulatory and policy matters are there. Cybersecurity risk is also one of the aspects, and therefore, there is this comparison of DC V2G versus AC V2G. And AC V2G is basically you are using onboard charger, the capability there of the vehicle itself for converting this AC into DC and DC into AC. Bidirectionality there, if you can see, is actually within the vehicle, while as in this DC V2G it is outside the vehicle. And if you can see if it is within the vehicle, this capability, then it becomes easy to have the scale of this V2G adoption, because every vehicle then is by default compatible for V2G without need for external bidirectional DC charger. So it has a lot of potential as such, but then there are challenges associated with AC V2G as well. And these are some of the potential benefits that I mentioned already. Bidirectional charge is built within this, and then the easy scaling that I mentioned. And this is one of the pilots or demonstrations that was done in Netherlands, where you can see here 2022 to 2025 is the this demonstration period, and it is using AC V2G. Around 500 V2G capable cars, which are retrofitted basically, are there that are part of this this particular demonstration, looking at the flexibility that these V2G is potentially going to offer from these vehicles. But there, as I mentioned, there are challenges associated with these V2G chargers, which is one of the challenges is that OEM comes into picture here. The OEM should actually be ready to have this V2G, AC V2G compatibility within the vehicle itself. And then what is becoming most important, one of the challenges is it is compliance with the grid code regulations, which we call in Indian context as grid connectivity standards. Their compatibility, their capability to comply with the grid standards, protection and other technical standards. And then this becomes more of a challenge in the regions where you are crossing the borders easily. Let us say in Europe, where you cross from one country to another country. Every country has its own regulation, and then how much compatible your car is going to be there to adopt the grid code regulation of different countries. Technically, it is feasible, but Practically, it is going to be challenging in terms of the cost, because you have to test it for different grid code regulations. If you want to sell the same car in different markets, which is not equally same issue. If we look at the large countries, let's say India, we are going to have more or less technical standards same across the country if going forward. So therefore, a car which is compatible there with the Indian requirements can actually go to any state in India and would not need to actually switch in terms of these grid code regulation requirements or technical grid connectivity standards. But there are these challenges in terms of OEM readiness, in terms of OEM willingness, and then the compatibility with the grid standards, grid connectivity standards. So those were some of the technical aspects of this V2G in terms of hardware, in terms of communication, in terms of DC V2G, in terms of AC V2G. And then now a little bit looking in terms of the heavy duty vehicles, the potential of these V2G from the heavy duty vehicles. So you can see here, why heavy duty vehicles are very important. If you see here, roughly now we have as of now around 1.76% these heavy duty vehicles. So can imagine in 2020 it might have been less than this, certainly not more than this probably. So, but nevertheless, this percentage of heavy duty vehicle is very, very low. But look at the right side plot. The emission is the share of emission that is coming from these different segments of the transportation. The emissions are very, very significant. If you see here, heavy duty vehicles are contributing to the majority of the emissions. So therefore, if we need to address the emissions from the transportation sector, we are very much required to address the emissions from all the segments, but more importantly from this heavy duty vehicle. But a heavy duty vehicles also provide a lot of potential opportunities given the size of the batteries that they carry and the charging infrastructure that they need. These are some of the examples of the existing electric buses that are available from different OEMs in the country, and many of you would have seen some of those models running in the city that you are in India. And then these are electric trucks that are there. Different trucks. Not much focus has been on the trucks so far, but of course electrification of the trucks so far. But the recent PM eDrive scheme is giving reasonable focus on the trucks also, and we are expecting that heavy duty trucks will get also electrified at a reasonably higher pace than what was happening already there. And then if you look at these different types of the electric vehicles, we can look at these applications which are there for general good carrying general goods, tankers, construction of wood carriers, steel, and miscellaneous applications. We have looked at this EV readiness and V2G. How much favorable they are V2G. We are considering that the general good, trucks that are carrying general goods may not be available for this availability of time, but the vehicle battery is going to be relatively higher. But availability of them for providing grid support, vehicle to grid support functionalities may be limited, because most of these trucks have to run over longer distances, and then they stay overnight, which they would primarily want to use for charging their trucks before they leave for the next phase of their journey. So in terms of availability, we see there is going to be those limitations. Similar issue we see in terms of the tankers also. Construction of goods carrier, we see that there is a potential, quite a bit potential of V2G functionality, V2G support. And similarly, the other vehicles that are there in terms of garbage disposal, municipality vehicles and others, we see quite a bit there also vehicle to grid potential. This is basically talking about the charging technology for these electric buses, which is one of the heavy duty vehicle segments that we have. And there is this depot charging is the most prominent one that we have currently in India in place. But there is also a potential of en route charging, on the go charging that is possibly option is there. Some of the latest developments in terms of the charging technology, which is now talking of the megawatt scale charger. So we have been talking of 6 kilowatt, 7 kilowatt in home charging to 50 kilowatt, 100 kilowatt range, or even 150 kilowatt range in, let us say, for light duty vehicles in the public charging, and then 400, 300, up to 500 kilowatt also in some cases in some parts of the world for electric bus depot charging. But what is now getting actually is being considered as a megawatt level charging potential. So here you can see this is this 𝐕𝐞𝐡𝐢𝐜𝐥𝐞 3, this 𝐲𝐆, which is the collaboration between 𝐕𝐞𝐡𝐢𝐜𝐥𝐞 and this China Electricity Council, where they have come up with this 900 kilowatt capacity 𝐕𝐞𝐡𝐢𝐜𝐥𝐞 charger that is capable of providing roughly around 1 megawatt power, which is very, very high given the existing charging infrastructure or types that we have globally available, which is having voltage of 500 volt plus, and then power is 500 kilowatt that I already mentioned. And then there is one more 𝐕𝐞𝐡𝐢𝐜𝐥𝐞 3.1 currently in the development with 𝐕2X capabilities, and that you can see here ultra 𝐲𝐵, which is being it's under development and being designed for 1.8 megawatt power capacity for these heavy duty vehicle trucks and potentially electric buses. There is also a parallel activity by this in terms of the CCS that you can see by Charin here, which is also under development, and it is also relatively of higher power capacity. You can see the voltage is considered to be around 1250 volt DC, and then 3 kilo current carrying capability with possibly this 𝐕2X capability. So the power capacity of the charging infrastructure is increasing, and that's where the role of vehicle to grid interaction is becoming more and more important, where these megawatt level power exchange can happen between the grid and these electric vehicles, and that has a lot of potential in supporting the grid in many ways. And these are some of the charging strategies that we have. This is also, we are working on some of the electric bus depot charging stations. This is showing one of the depots that we work with in terms of the charging profile. You can see here, it is predominantly night charging that you can see in this particular depot. This is the actual data, and then during daytime, because the buses are actually on their routes, so therefore not many are available for charging. But the night charging is primarily the one that is being adopted here. This another electric bus depot that we're working in, where this charging infrastructure is planned for this particular depot, having total number of chargers being 8, and then charger rating of each charger is 200 kilowatt for 60 buses, electric buses, and the battery capacity considered is not considered is here in this case is 400 kilowatt hour actually. And then we are considering this is showing the bus arrival and at the depot of course in the evening, and then till late night buses are coming, and then they are staying overnight. During the daytime they are not available much in the depot. And this is showing the charging profile on the right side of these buses. You can see the night charging primarily, as I was mentioning, and daytime is only, you can see, opportunity charging that is being used there. And this is showing little more analysis in terms of the transformer loading, in terms of the cable loading of this bus depot. This is another bus depot that we are working on, and this is here you can see we're having roughly around 60 electric buses that are being catered through this bus depot. And again, here we have done this grid integration analysis looking at the other aspects as well, where you can see the transformer load, means there are 2 transformers, and then the power drawn and the cable loading and others that is there in the depot. And we're looking at some of the issues with some of these bus depots, where which are, some of them are very local, locally driven challenges. And this is another example of the school buses, where school buses are being used for the vehicle to grid. 2020 to 23 is a period of this vehicle to grid using school buses. And the potential you can see here is that you can see estimated annual V2G revenue for this, you can see here for different cases is projected here for different years 23, 24 to 27, and then payback period under different models, business models is shown here. For example, you see baseline no funding or revenue for the short school buses, it is around 21 years. For classic large school buses, it's around 19 years, and then flat front large is actually around 23 years. Then with some additional funding, viability gap funding, and then other funding, you have different models again in terms of the payback period, and then they can provide these. You can see avoided capacity, peak load reduction, energy arbitrage, and ancillary services from this. Similarly, there is one more project here. You can see first all-electric bidirectional V2G school bus fleet launched in Oakland, and here you can see these electric school buses offering the V2G potential support in this particular pilot project. We are also one of the focus of this study is the business models for this vehicle to grid, which we are right now is actually work in progress. We'll have next webinar focused on the business models applicable to Indian scenario, Indian EV ecosystem for this vehicle to grid application. So with this, I would like to conclude the presentation. I think probably I overshoot my time. So I'll stop my presentation here and hand over back to Pratosh, please.
Thank you, sir, for your interesting presentation. Now, going ahead, I would like to invite Mr. Bjorn Christensen for presenting on global status of VGI and V2G. Bjorn Christensen is the Managing Director of Next Dimension, a California-based consultancy specializing in vehicle-to-grid e-mobility and CO2 reduction strategy. Over to you, Mr. Bjorn.
Thank you very much. Let's start with a typical question. Can you see my screen? Just a moment. Here. Can you see my screen now and hear me?
Yes, sir. Yes, sir.
Super. Thank you. Thank you very much for inviting me to this webinar. I would like to give you an overview of the global status of vehicle-to-grid integration, or VGI, and V2G. So this would be with a broad brush, painting a big picture. If we look at the very thin atmosphere that we have, and here's a slide that I borrowed from NASA, and Al Gore has also shown it. We are very close to the space, and here separated by our atmosphere in blue. So we all want to have a habitable planet for the next generation. The problem is that climate change is a global problem that threatens the health of humans and all other life on Earth. So the solution, very simply, is the energy transition, making electricity green and electrify everything. We feel that bidirectional charging, or V2G, is a crucial technology that enables the energy transition. And the vehicle-to-grid provides large-scale flexibility at low cost, and flexibility is a key to enable more renewable and to keep electricity rates affordable. This is an issue, the last one, keeping electricity rates affordable. Where I live in California, we are paying 63 cents per kilowatt hour in the peak, and they're still claiming that they will raise the rate this year. So everything we can do in order to keep the electricity rates affordable is important, and V2G plays a major role. So here is a study from the World Energy Forum, and this is basically showing that the energy transition is only possible if we increase the flexibility. The IEA expects short-term flexibility needs to grow by 4.5% times by 2050. And we can see here that the flexibility need comes from demand, from wind, from solar, and that the supply comes from different entities, where electricity storage from electric vehicles and batteries is a very important factor. So if we look at the EV batteries, they will be by far the largest storage capacity in the grid. If all EVs were V2G, of course they will not be, but they would be providing a vast amount of inexpensive storage. And here's some scenarios again from International Energy Agency in Paris. And we can see here that in 2030, we would have about 5.5 terawatt hours of battery capacity in the grid. The light blue is from cars. This is the dark blue is from utility scale batteries and behind the meter batteries here. And what does 5.5 terawatt hour means? Well, 1 terawatt hour can power 10 billion 100-watt light bulbs at one. The state of California could be powered for 1.5 weeks, 100 million homes for an hour, and world data centers for about 15 days. There's another issue that we have to focus on. That is utilizing the world's resources in an efficient way. So we must really look at what is a capacity factor of the battery. Here are some capacity factors typically for other technologies. And we can see that it's very miserable for a car, electrical car, that is only used for driving maybe 2 or 3 days at a time, hours a week, a day. There's a capacity factor of between 8 and 12%. And V2X has enormous potential to increase that battery capacity factor. Now, before we go into vehicle-to-X or vehicle-to-grid, I think it's important to look at the taxonomy. And here's a working taxonomy that I've been using for a long time. It's not an official one, but it takes the vehicle-to-grid integration concept, which was basically coined in 2014 by California Energy Commission, which is divided into unidirectional power flow, or V1G. It could be dumb charging, fast charging, smart charging, but unidirectional. And then bidirectional power flow, which I've termed here V2X. V2X, bidirectional power flow, can be divided into 2 major categories. If we are on grid and following the grid frequency, and the grid is determining the voltage and the frequency, and our vehicle's grid will only follow that frequency and the voltage. We can do behind the meter, which we call vehicle to home and on grid, and vehicle to building on grid. This is behind the meter, typically with a home energy management system. Then we can do vehicle to grid, where we can basically provide services to the distribution grid, or we can provide services to the transmission system operator, which is in front of the meeting. So this is all when we are connected to the grid and following the grid. Then in cases when the grid goes down, we can move off grid, and this is here the second category, which we call grid forming, where our inverter, whether it's in the car or whether it's in the charging station, has to provide the frequency and the voltage support. And that can be used to provide emergency services either to the building or to the home. And then the transition, of course, between these two, when the grid comes up, we want to go on grid again. And then over here on the left, we have also bidirectional vehicle to vehicle or vehicle to load, which is off grid and where no EVSE is involved. So where are we now in bidirectional charging? V2G was invented a long time ago. Let's just look at the pioneers that showed us that it really can be done. There was a company was founded called AC Propulsion in 1992 in California by a guy called Al Cocconi. And then there was a typical trio of very important people that was basically the basis for Tesla, Martin, Mark, and Tom Gage. And they came up in 1996 with something called the T0, which was basically AC V2G. And it had regenerative braking and 0 to 60 miles per hour in 3.7 seconds. And this is the way they actually charge the car, because they have issues with the batteries. So that they basically have a little trailer where they can charge the batteries. And here's another view at some of the tribute to the V2G pioneers. This is in Delaware. And this is one of the first vehicle-to-grid cars that was done by Professor Kempton, shown here on his left, and his team at University of Delaware. So where are we now? Let's continue. We have had more than 150 V2G trials and projects that have been conducted worldwide. And it's fine because we have learned important lessons. California Energy Commission introduced the concept of vehicle-to-grid integration in 2014. And we also know that the bidirectional EV supply chain has improved substantially. For example, Volkswagen with the MEB platform in Europe has about 40,000 cars on the road in Sweden alone. They're all bidirectional, via DC bidirectional, but they have not been released. So there's a software release that needs to be released them so they can actually provide V2G services. The California Public Utility Commission approved DC V2G in 2020. So that is allowed in California. And we are now on the way to approve AC V2G, as Professor Sakia mentioned, because AC V2G is important because of economics. And lastly, but not least, ISO 15118-20, that means the EV-EVSE protocol was released in April 2022 as an international standard. So despite all this, bidirectional charging has not scaled anywhere in the world so far. So we need more pragmatic, concrete initiatives to scale. So where are we now in California? The reason I mentioned California, that's where I reside, but I also believe that California is very far ahead on vehicle-to-grid. So we have something called the Rule 21, which determines which distributed energy resources can be interconnected to the Californian grid. It was invented or applied first in 1982, it's a long time ago, and it was designed to meet needs of small non-utility owned generating facilities, basically distributed energy resources that would allow them to interconnect to the grid. So the current status of Rule 21 applied to electrical vehicles or V2G, as I mentioned, vehicle-to-grid DC, where the inverter is in the EVSE, can be interconnected under Rule 21 now. And it has to be applied or tested by UL 1741 SA or now SB. Vehicle-to-grid AC is on its way to be approved. And there's another UL specification, Underwriter Labs specification, 1741 SC certification with a lot of test cases. It's in public hearing right now, and we hope that will be approved next year. So hopefully next year in California, we will have allowance to connect both DC and AC V2G. Now, if we look at the trials that are going on, and these are trials in California, I think Professor Sakia has already mentioned the very large school bus, 79 school buses here in Oakland, which is about half an hour from where I live, and it's run by Zoom. These school buses are from a company called Ride, which is basically BYD, and they are doing V2G services, as you can see here. Now, also, I'll skip over this because Professor Sakia has already mentioned that, but the heavy transport sector is very interesting because it has a lot of pollution coming from those heavy-duty vehicles. They have very large batteries, and depending on which buses they are, they have very good user profiles that can be applied to V2G. Some of these buses on heavy-duty vehicles, of course, are not really applicable for V2G because of the use cases. There are other activities in Europe. Here is an activity called bidirectional laden or VDL in Europe. It's heavily dominated by Germany. It's a very good initiative, and you can see some very heavyweights are involved in that project. Mercedes-Benz, Volkswagen is involved, BMW is involved. And so this is something that tries to drive on a European level all the issues that needs to be solved when we want to scale vehicle to grid, not only from a technical perspective, but also from the regulatory perspective. So here's another example of a big trials that just completed about half a year ago in Switzerland, where there were 50 Honda E cars that did the vehicle to grid integration. So it showed that 𝐕𝐞𝐡𝐢𝐜𝐥𝐞, and this is in DC, works, but there are a lot of issues that are non-technical nature, and I'll get into that in a moment. Zakir also mentioned Renault. They launched an AC bidirectional charging in Utrecht in 2025. So this is an AC bidirectional charging with the Renault 5 together with 𝐕𝟑 Solar and my wheels. And China is going bidirectional, which is very important. So there is a lot of activities going on as we speak in China to also to play a major role in vehicle-to-grid. So the Chinese manufacturers, of course, are very interested in also exporting the technology, and for example, to Europe and other parts of the world. So I think we should take that also very serious, what's going on with V2G in China. Now, one of the issues in general that we have of today's solution, and there are a lot of very good solutions where one car manufacturer works with one EVSE and works with one DSO, distributed system operator. These solutions, V2G solution works, but they're based on proprietary protocols like the DIN or the ISO 15118-2 with some modification. And these are singular grid code support. These are silo solutions, and they do not scale. They do not scale well. And so there's a new initiative, which is called Task 53 under the International Energy Agency, which is basically focusing on vehicle-to-grid interoperability. And they want to close the gap, move the needle, making a difference on an international level. And there's a consortium within Task 53 that want to come up with a golden EVSE standard, de facto standards derived from 15118-20. It's not a new standard. And then supporting harmonized grid codes where there will be an interoperability between at least 3 EVSEs and 5 DSOs. Now, IIT Mumbai, very important grid integration lab, is also a member of IEA Task 53. And you can see here the countries that are now members. United States is a member, the EU is a member. And very important is that the GIL and IIT Mumbai is also an observer in this very important initiative. Now, how do we go from V2G trials to scaling? We need interoperability. It's not a silver bullet, but without interoperability, there will be no meaningful scaling of V2G. So there's a lot of V2G solutions, as I mentioned, more than 150 trials, but they have not resulted in any programs. So we need technical interoperability. And then based on these trials, we need to feed them into the standard organizations. And then we need to get the interest organizations involved to submit proposals for policies, regulation, tariffs, and harmonizations. And of course, we need the policy organizations to be involved. And this is a two-way street. So we are very far ahead on this point. We're very far ahead on this point. We're working well on this one. But here, there's still a lot of work to be done in order to make V2G real scalable and also economically available, interesting for the participants. So I'm just at the end of my presentation now, and I want to show you two slides that I did also for the project that I was involved with implementation of Vehicle-to-Everything in India. I feel very strongly that India can stand on the shoulders of 15 plus years of worldwide V2X experience. We know that the OEMs have now entered the markets, so there's an accelerated supply of V2G technology. The international standard, as I mentioned, is almost ready. There's still some work to be done between interworking between different protocols. The interconnection is well understood, both AC and DC, that means for grid code support. And market models have been evolving. So there is really a time to catch up and leapfrog. The V2G markets are still in their infancies. And I think it represents a unique opportunity in this very turbulent time for India. We're still in the beginning of the mobility with less than 1% of vehicle electrified, or about 6.5% of sales of EVs in 2023. A strong educational system, world-class universities, world-class software, and a competitive automobile industry. Also important, Vital's EV power flow can reduce the cost of upgrading the grid to support millions of EVs. Right now, we're talking about thousands of EVs, but we will very soon have millions of EVs in there, which will put a lot of strain on the, especially the distribution grid. We believe that V2X EVs will become a very important asset of the Indian grid as we move forward. It also opens up opportunities because the world export opportunities, because the world is moving towards V2X solutions. So with this, I would like to conclude my presentation. I know that I've exceeded my time with 3 minutes, but thank you very much.
Thank you, Bjorn, for your insightful presentation. Moving ahead, I would like to invite Mr. Angshu Nath for presenting on battery degradation in V2X systems.
Thank you, Pratosh. Am I audible?
Yes, you're audible.
I'm sharing my screen. Let me know if it's visible.
Yes, it is visible now.
Thank you. So thank you. Good afternoon, everyone. So today I'll be giving a presentation on battery degradation in V2X systems. So as we all know, so battery is one of the critical components of EV, and most of us are worried that if we have V2G from the EV battery, won't it lead to battery degradation? So when we say battery degradation, it refers to a gradual decline in the EV's ability to store energy and deliver energy over time. So there are two main degradation phenomena. One is the capacity fade, where the total energy stored in the battery is reduced with time and affects the range of battery. And next is the power fade, where the maximum power that the battery can deliver reduces with time, and it affects the acceleration and performance of your vehicle. So the key characteristic of battery degradation is, the first is battery degradation is not linear. So we cannot say just by increasing the usage, the degradation is increasing. It's a non-linear phenomena. Second, it's unavoidable. So whether we use the battery or the battery lies idle, it will get degraded with time. And thirdly, the battery degradation is dependent on multiple different parameters, and not just a charging or discharging activity. So why degradation matters is because degradation directly relates to your EV lifespan and the terms and warranty of your electric vehicle battery. And it impacts your vehicle resale value and your economics. It also drives the decision battery design, how you design the thermals of a battery, and whether it's suitable for V2G applications. So if you look at battery degradation, there's two specific pathways. One, we have the calendar aging, where the calendar aging natural phenomenon is the natural loss of life of battery with time. And next we have cycle aging, where it is a loss of the battery health due to charging and discharging cycles. So in calendar aging occurs even when the battery is not being actively used. It's accelerated by storing the battery at high SOCs, where SOC state of charge, it basically means how much energy is in the battery at the point at which it's storing. And second is at what is the ambient temperature when the battery is being stored. So the calendar aging is accelerated with high temperatures. So for example, an EV which is parked at full charge for long duration is degraded faster, even if it's unused. It's better to, if you're storing a vehicle, it's better if you leave the vehicle at a lower state of charge. So for cycle aging, the degradation occurs through repeated cycling and discharging. It's accelerated by, it's dependent on how deep, what is the depth of your the charge discharge cycle, how frequently you're charging the battery, and what is the current at which charging or discharging the battery. For example, a taxi running full daily charge cycles will degrade faster than a personal EV used occasionally. That's a rough example. Now, if we look, now coming to cycle aging, calendar aging. So in calendar aging, battery temperature associated two primary factors that influence the aging of the battery. If we look at the effect of temperature, so if we store a battery at higher temperature, the degradation is faster. So if we look here so it's a experimental study where a battery of 3 ampere hour rating was stored at different for 3 different battery sample of battery was stored at different temperatures. So if you see here, when a battery is stored at higher temperature at 45 degrees Celsius, the capacity fade was much higher. And the capacity fade was minimum when the battery was stored at a normal temperatures. So just like human beings, battery likes to be stored at normal operating ranges between 20 and 30 degrees Celsius. If we store at much lower temperatures, even then the life of the battery is impacted. Next, if you look at the SOC, so as I earlier mentioned, depending on at which SOC you store the battery, your degradation will be higher. So compared, if you store a battery at 20% SOC, then the degradation is much lower compared to if you store the battery at 100% SOC. And again, this study was done in an experimental study where different samples of the same battery were stored at different SOCs, considering the storage temperature being constant. So as we can see, the calendar aging is impacted both by your storage SOC and by your temperature at which it is being stored. Coming to cyclic aging, so cycle aging is influenced by your charge, your current, the C rate of the charge and discharge cycle, the depth of discharge for each charge cycle, the number of such charging and discharging cycles that we are going through. So if you look at the charging C rate, so typically when we have C rate means at which 1C means for a battery with X kilowatt hour, it takes exactly 1 hour for the battery to be full. So that's how C rate is defined. So as we increase the C rate, with faster charging a battery, our cycle life decreases almost exponential. Similarly, a similar relationship is seen between your cycle life and your depth of discharge. If we do deep swings, let's say 90% swings, where your battery goes from 100% to 10% and from 10% back to 100%, so deep cycles, these are deep cycles. Again, your battery is deteriorated exponentially quicker compared to if we had smaller depth of discharge cycles. Now the effect of battery, so that these parameters are also the degradation also is a function of whatever battery chemistries are we using. So as we know, lithium-ion batteries can have different chemistries based on the electrolyte use, based on the cathode material use, based on the anode material use. So here this paper compared 3 different lithium-ion chemistries. Then first we have the nickel manganese cobalt chemistry, NMC battery. The second we have nickel cobalt aluminum oxide battery, NCA battery. The third with lithium iron phosphate battery. So if you see here in the graph, so on the top we have the capacity fade, how the capacity fades for cell A, cell B, cell C for a constant temperature 25 degrees Celsius and for different charging rates 3, 4, 5 amperes. So if you see here, so cell A, which is a nickel manganese cobalt battery, its degradation is much faster compared to cell C. So again, it basically shows that with different chemistries we have different your charging your degradation profile. Same with relative resistance. So resistance basically talks about power fade. So how quickly you're losing out on the power available with the battery. So cell C has a much slower or a much better degradation profile. So it doesn't degrade as fast, but cell A has a much faster degradation profile. But on the other hand, so although cell C looks better in the degradation, but cell C also has a very less energy density. So if you see energy densities, cell C has around 93 watt-hour per kg, but cell A has 240 watt-hour per kg. Now, depending on use case, we may want to use different battery chemistry as per requirement. The second, we also want to show how this battery chemistries affect the degradation of a battery with different temperatures. So if you see here, so cell A, let's say in cell A at higher temperature, it performs much better compared to at lower temperature. At lower temperature, degradation is much faster. Whereas on the other hand, in cell C, the degradation is much faster at for higher temperatures, and degradation is much slower for lower temperatures. So depending on which kind of environment you want to use the battery, also dictates which kind of battery chemistry you want to go for. So what this shows is the battery, your degradation of battery is not dictated by your charge and discharge cycle. There are multiple parameters in play here. So if we look at the comparison between which is dominant factor, whether calendar aging is dominant or whether cycle aging is dominant. So this study was done in Harvard, where the blue surface basically shows your total degradation, the brown surface your cycle aging, and the green surface your calendar aging. Now on the x-axis, we have your C rates. On the y-axis, we have an ampere hour throughput, what is the total hour energy throughput, and the z-axis, we have a capacity loss. And these four different temperatures: 10 degrees, 20 degrees, 34 degrees, 46 degrees. So if I look at 34 degrees Celsius figure, if you see here, your calendar aging pretty much always dominates over your cycle aging. So most of the time, so what does it mean is, for a situation such as India, where temperatures are pretty much high, our calendar aging is going to dominate battery degradation compared to cycle aging. So what is so in for V2G, your V2G cycle just affect your calendar your cycle aging and not a calendar aging. So what it may show is maybe V2G doesn't have as much an impact. So we'll see in the later slides what it actually does. But again, the highlight here, the calendar aging is a much dominant factor compared to cycle aging. So this is a study done in Denmark where 10 V2G capable EVs were provided frequency regulation for 15 hours per day for 5 years. And this was an actual study, it's not a simulation-based study. So these are the 10 different electric vehicles that they use, and this is the amount, the duration for which they provided the frequency service, daily average duration. And this is the, again, daily average energy throughput. So as you can see here, it underwent a very strenuous vehicle to grid application. Now, after the end of 5 years, they compared the state of health of each battery. So this magenta line, it is a measurement estimate. It's an estimation based on the model, and this markers are actually the measured state of health of each individual vehicle, where FF01 is the first vehicle, FF10 the 10th vehicle. So if we see after the end of 5 years, the state of health of the battery came down to around 80%, 82, 85%, in that range. But again, it has been seen here for this application, it was a very strenuous vehicle application. But again, if we look at the calendar aging and the cycle aging, so on this left side, they have given the annual degradation. We had the calendar degradation, the cycle degradation, total degradation. On the right hand side, we had the aggregate degradation. So if we say at the end of the 5th year, the average total degradation was 16%. But of this 16%, around 12, around 11 to 10 to 11% was contributed due to calendar aging, and not because of cycle aging. So again, it shows that the calendar aging is dominant in here as well. So irrespective of whether the vehicle was being used for V2G or not, this calendar aging would have been anywhere there. So due to vehicle to grid, a small percent of the cycle aging has added on top of it. But again, the calendar aging is dominant in this as well. Now, depending on V2G applications, again, your impact on the battery degradation will be different. So again, in this paper, they took 3 different services: peak load shaving, frequency regulation, and net load shaping. Again, net load shaping was the most strenuous exercise. So if you see here, the baseline is where there was no vehicle to get service. Now, if we add frequency regulation on top of it, the degradation increased by around 1.5%. If we peak load shaping, the around 1.7%. If it net load shaping, the degradation increased by around around 2%. So the impact of V2G on your degradation of the battery is quite minimal. Then there is one more case study where they went for optimizing a V2G for battery degradation. They want to minimize the battery degradation because of V2G. So they modified the storage SOCs and they modified the battery cycling in the optimal SOC region. And they did this load leveling application, and for 120 weeks participating in this project. So what they actually observed was, without any V2G, the degradation is much faster compared to an optimized V2G algorithm. Because of the optimized V2G, they're able to slow down the degradation, and the effect on the batteries was much better compared to if there had been no V2G. So to conclude with, so battery degradation is much more nuanced than a simple function of energy throughput, and typically calendar aging is a dominant factor. So although V2G is a factor, but the incremental variant here, because of V2G, is roughly around 1% per year, making it relatively minor. And with upcoming batteries, which much better battery chemistries and much better V2G algorithms, the concerns around vehicle to grid induced variant should be much lesser. I think that's it for this presentation. Thank you.
Thank you, 𝐸𝐞. for your interesting presentation. Now, I would like to invite all of you to join us in a panel discussion on the readiness of Indian stakeholders for adoption of V2X. For panel discussion, we have Mr. Ramkrishna Singh, Head EV Charging Operations Tata Power, Mr. A.K. Rajput, and Mr. Bjorn Christensen as our esteemed panelists, and the panel discussion will be moderated by Professor Zakir. Over to you, sir.
Thanks, Pratosh. Before I start, I would like to mention again for the information of the participants that this panel discussion is on the readiness of the Indian EV stakeholders for V2X adoption in India. And as already announced, we have panelists, Mr. Bjorn Christensen from Next Dimensions, who carries a lot of experience in V2G space, international experience. And then we have Mr. Ramkrishna Singh, who is helping the EV charging infrastructure rollout at Tata Power, has in and out details of how the field is evolving and what are the challenges at the ground level from the charging infrastructure particularly, and of course in general in the EV space. And then we have Mr. A.K. Rajput, member Power Systems CEA, who has also kindly agreed to be part of this panel discussion to bring his perspective, both technical side and also the regulatory aspects from the CA perspective. This is, in my opinion, very interesting development that is happening across the world, and most of the participants and experts would agree with that. So I would start with the first related question, which I briefly touched upon in my presentation, and this is for Bjorn, given that you have been in the field for a long time and you know the overall development in the space. I was talking about AC versus DC V2G option, which you also briefly touched upon in your presentation. So can you provide us, the audience, your perspective in what should be followed, AC V2G or DC V2G, or the combination of the two, and how do you foresee this technology choice in terms of V2G adopted as we move forward in the journey of vehicle to grid implementation? Beyond.
Yes, thank you, Zakir. If you look back a little bit on some of the projects that have been done a very long time ago, for example, in 2013, at my previous company, we did a very large scale V2G AC at the University of Delaware, which was providing frequency regulation to PJM. And that was done with the AC propulsion drivetrain. 45 kilowatt hour battery, and we had also the AC part, which was the inverter in the car. Now, that did not support the grid codes. After that, we have gotten more, but it was a very good solution. After that, we have then seen development both on the DC and the AC. And I think it's fair to say, if we look at Europe, the tendency has been to go towards DC because it's simpler. Why is it simpler? Because you have to look at the typical processes and established working methodologies that the grid operators have. They would like to go out and approve an installation that is capable of sending energy back into the grid. That means it's not only a load. So they have inspectors coming out, checking out and saying, okay, it's a stationary device and it has some UL certification, or it has whatever SE certification. So that's why it's easier to implement it in the operational procedures of the grid operators. Now, from the car manufacturers, it's also easier because the only thing that they would have to do is to have a bidirectional capability that is DC between the EV and the EVSE. Now, the problem about that solution is that it's expensive. It's relatively expensive. If you look at the typical solutions out there today, you are talking about a substantially price difference between a DC V2G solution and an AC standard unidirectional solution. So, but it's approved. You can do it now in California. You can interconnect to the grid. All the processes have been set up. You have to test it according to certain test procedures. It has to be tested by national test lab, recognized test lab, and so forth. Now, if you move to the AC, and the reason for AC has such a big interest is that we believe the cost is much lower. But it adds the additional complexity that you have a moving inverter. The moving inverter, as yourself mentioned in your presentation, is in the car. And that puts more strain on the car developers. And the car developers then have to somehow come to an agreement with the grid operators to certify his inverter. And that is something that's difficult for the car manufacturers because they have been self-certifying. They don't want an extra entity come in and test whether they can do that in their car. So, but it's coming, and it's coming slowly. So I think that we will see in the marketplace, we will see both AC solutions and DC solutions, depending on car manufacturers and use cases.
Thanks, Bjorn, for giving that perspective on V2G, DC versus AC. My next question is to Rajputji. Given that you are from the technical side of the electrical power and with vast experience that you have in the Indian power sector, and then coming from the department which is responsible for various regulations and other technical connectivity standards, how do you see the outlook of V2G adoption in India in the context of course, with vehicle to grid integration, but also in the context of their potential support that they can offer to the distribution system, particularly in terms of demand side management, in terms of peak load management, in terms of, let us say, shifted energy consumption from peak load to off peak load, and then possibly the renewable energy uptake of rooftop PV during the daytime when the load is less in the distribution system, how this could potentially help in better integration of renewable energy integration, particularly at the distribution system. So what is your opinion on that?
Yes, sir. Thank you, sir. First of all, that every drop of water is to be saved. Similar thing applies here, that each and every unit or a fraction of the unit of electricity need to be saved. Electricity in terms of the energy unit, that is a kWh, becomes more costly when the peak is approaching up to its maximum. Sir, am I audible, sir?
Yes, we can hear you, please.
Yes. So I want to be sure. So here two things would be necessary. First is we have to decide what our ultimate aim is very clearly, and for how long and how much duration we will be needing the support from these stationary vehicles. And ultimately, what will happen, the charging cable sizings and the charging infrastructure and the V2G infrastructure need to be standardized. it should not happen that one type of the vehicle, say one type of the bus, one make of the bus and the another make of the bus creates problem at a later date. And in the buses also, see, we have generally 52 or 60 or 58, 60 seaters of the type of the buses. In coming days, the things may be that when the new sub-townships are being developed and they are, say, very, very costly assets, say one flat costing 3 crores to 5 crores and all those things. So you will naturally need the transport facility from those places. Most of the people are working class and they rush to the corporate offices and the other government offices and the office complexes. The smaller sizes buses in India, they are known as the tempo traveler or say minibus type of the thing. They could also form part of that. And those housing complexes, the new complexes, be designed in such a way that they have the sufficient parking spaces and the charging and flowing back of the energy arrangement there. Whatsoever the existing bus depots are there, they have more or less the sufficient space. If required, those could be modified to be, say, of double storage type or like that.
Okay, I think we lost the connection with Mr. Rajput. So while he's getting reconnected, I would request Mr. Ramakrishna Singh to throw light on this renewable energy based EV charging. I know that Tata Power is already providing the green power based EV charging service in different parts of the country. Can you throw some light on that? While providing this green power based or renewable energy based charging services to the consumers of this EV charging load, is there additional economical aspect, commercial aspect that is coming up? How much additional cost is there for catering this EV charging load from the green power only? How do you see that we can scale it up, given that you are already offering it at some places? We can scale up it at the pan-India level. As I was mentioning earlier, the basic purpose of this electrification is to actually cut down on the carbon emissions from the transport sector, which will be truly achieved only if we are able to provide 100% RE-based charging. And then 𝐕2𝐺 can help us in a better way in that. Over to you, Mr. Ramakrishna.
Thank you, Professor Zakir. And it was quite interesting to listen to your presentation, Mr. Bijan's presentation, and Ansu's presentation. I'm quite happy that academia and the industry is working very closely. And very soon we would be seeing the 𝐕2𝐥, 𝐕2𝐺 in India coming in. So I think it's a great effort and kudos to all of you. So that see, Tata Power has already been forefront of providing the green and renewable energy to our customers, and in the same direction we had taken up with the state regulators for giving the options of providing the green electricity with certain differentiated tariff. So while differential tariff is not much, it's only notional value, and it also adds price. So we differentiate those customers that those are the green customers. So not only the EV charging on the green tariff, but in Mumbai, we are also providing the entire electricity consumption for the green as a green tariff, as a green energy option. So apart from Mumbai region or Maharashtra region, we are also, as of today, around 1,400 chargers pan-India are on the green energy supply. So we had taken up with a couple of other state regulators also, and around 4 or 5 states have already come up with the green energy option, green electricity tariff option, and we are deploying those our existing chargers. We are migrating from the normal energy to the green energy, because a lot of customers used to come to us and was telling that what is the use of having the electric vehicle unless you completely fuel it with the green energy, because our existing Indian mix is almost still around 75% is coming from the coal and the gas sources. So only 25% is coming from the renewable sources. So that is how we have initiated this green initiative, green tariff option for the energy customers, not only for the charging in Mumbai, but even for the other household consumption also. So that is one part. And another part, we are also encouraging people to opt for the RE integration along with the grid connectivity. So I was in a field visit, and I was interacting with one of the retired bank employee, and he told me very interesting story that post retirement he had some money and he bought electric vehicle. He also got rooftop solar installed. And he found out that his existing ROI is better in investing the rooftop integrated solar, having the EV, rather than keeping that amount into the bank. So I think the Indian customers are very innovative, and they are evolving. They are bringing all those concepts into the implementation. And with the PM Surya Ghar Yojana, which we are implementing across India, we are encouraging customers to also opt for the electric vehicle, and vice versa. If we are putting, like Tata Power has already put around 130,000 plus home charger, but unfortunately those are not V2G or V2X, and we are very keen to see those V2X or V2G chargers, while we are also experimenting with ISGF, with one of the American university, on the how that retrofitting can be done. I'm not sure whether, I think you must have seen that in ISGF event also. Some of the colleagues might have seen that. So we are also working on that. And I'm sure that this V2G or V2X is going to come very soon in India.
Yeah. Thanks, Mr. Ramakrishna, for providing the inputs on this development that you are already, working at, providing the electricity from the renewables. Providing the charging services from the renewable energy based sources, which is also very important aspect, as I was highlighting earlier. I would like to just understand if Rajputji is back. Can you hear us, Mr. A.K. Rajput?
Yes. Am I audible, sir? Somehow
yes.
camera of the computer not working. Anyway,
Yeah,
I will be speaking. Oh, I think please. Sometimes it comes, sometimes it goes. Anyway, whatsoever may be the case. Actually, this we should, as I told in my keynote address also, we should not leave behind, and we should be futuristic. And by futuristic means, we should develop that what best we could do. It is basically the overall flattening of the load curve. And that flattening of the load curve requires various measures, and at different locations, not at one location itself. So when the locations are distributed, see the conditions of the larger cities like Mumbai, Delhi, and Chennai and other places. So each sub area is a load center, and those load centers need to be developed in a way that we can manage our resources in a good way. And that is the concept of DER also. So the same concept applies here. And whenever the new areas are being developed, they need to be equipped with full type of such facilities that what we are doing will be lasting, say, for next many years. Not few years, but many years to come. the thing is that once the infrastructure is built, and if it is confined only to something, then it becomes a limitation and a great constraint. And we face a lot of problem, whether it is widening of the road, increasing the capacity of the parking spaces, or increasing the capacity of the plugs and sockets. Now, say vehicles are with certain kilowatt of the batteries. In future, the higher and higher capacity of the batteries will come. So we have to think in that. Further, these cables, what I was telling is, have to be designed maybe with a slightly oversized. Why slightly oversized? Because with the change in the power quality and with the erratic use, which is imminent, which may happen either by the persons not knowing the correct use of the devices, or say misusing to some extent, and like that. So that margin need to be built in the cabling, or what we call the leads, or what we call the cords, whatsoever you name it. Then part of the RE integration is basically the fluctuating and as well as also containing the harmonics and other things. So when DC to AC will be injected into the system, so naturally the harmonics are bound to happen, and we have to have proper precautions for filtering those harmonics also. And particular part will be what will be the commercial arrangements, that I am getting the electricity, say from either from a public charger or from my garage, charger in the garage or in my premises at a particular rate. So time stamping has to be done, and this time stamp should have the unique identity that from which place the electricity is getting charged, so that proper commercial accounting is taking place. And we can build in at a later stage, maybe the extended part of the study, that how much carbon credit it will be contributing, though small, but it will be contributing, because it will whatsoever the energy, say amount of say energy is 10 kilowatt, the load, the 10 kilowatt equivalent it is supplying to the grid at the time of the peak. So this 10 kilowatt it is local, and had this 10 kilowatt flowing through the grid from the central grid and from some say grid substation, so it could have incurred some extra amount of the losses part into the system, and at the generating station it could have contributed that much incremental kilowatts. So that type of the modeling and finer modeling, and for that whatsoever is being done, what we call it the aggregate model and all those things. And now the concept is of the gated colonies and the well-planned colonies and all those things. So those facilities need to be utilized, and where these type of the buses and this type of the things there, maybe the multi-storied concept, parkings and the charging facilities could be built in there with sufficient cooling and circulating air spaces, where the people can also walk freely, so that if something happens, something is going to happen, the proper safety measures are also there. And this way we can proceed. Not only these parking lots of the buses, that is the bus depot. Here in India, the of two type. One is the state transport buses, or the say in Delhi you call the Delhi Transport Corporation, or in Mumbai is the BEST. But in addition to that, there are normal buses as well as the long distance buses, overnight buses we call it, where people take rest, go in a sleeping mode, and all those, the sleeper type of the buses are also there. So naturally they will consume higher amount of the power and all those things. They also need the sufficient charging when these are converted and when these are say transitioned to the electric type of the vehicles. And for example, maybe in the future run, the hydrogen fuel cell type of the vehicles. At present, what we see, we don't think that there is some fixed parking lot for them. They are located or they are say parked at convenient places wherever they find, and some parks and all those things. So particular charging stations for them, the charging facilities are not there. And whatsoever the existing guidelines of the Ministry of Power are there for the charging, this aspect is missing there. And particularly for the trucks, they don't have any such depot, though they have the transport nagar, but a very organized way of their parking and keeping them safe, parking and charging them with the electricity, where some risk is also involved. Electricity is associated with some risk always. So that type of arrangements are not there. What suggestion I gave at that time when this guideline was being prepared, that if the space is available and the capacity is available in the bus depot for the charging of these heavy vehicles, heavy private vehicles also, that should also be allowed. But somehow this is missing and need to be incorporated in subsequent days. That is my view from this particular point. Next thing is that when these batteries will be there, of course, some recycling attempts are being made, and other experts may be knowing. So when the battery will be exhausted and will be of no use or little use after say 8 to 10 years, then at that time, the recycling, mass scale recycling, which would be efficient and at a very competitive rate, and which will yield the higher returns in terms of the metals and in terms of the critical minerals also. That also need to be attempted. So far in the coming days, what we are seeing is only the lithium variety of the battery, they are seems to be feasible. Other technologies, of course, are being experimented, some in design stage, some in R&D stage. So particularly for the India, we have to see and secure the sources of the lithium also. President or Prime Minister of Chile came recently. I do not know what happened, what dialogue must have gone, but I expect that this particular dialogue must have happened among the government to government, because Chile is also a source of the critical minerals, particularly the lithium, and some long-term ties have to be ensured. Otherwise, without the supply chain of the batteries, either the imported component, better it would be that we manufacture the high capacity battery, its battery management system, and all other component parts in India. That will give us a confidence that the things will be available easy, particularly say for the trucks, because the trucks in India are owned by an individual. Maybe some corporates must be having few trucks, a fleet of the trucks. Similarly, the cars could also be like Blue in India, a brand Blue is here, in particularly in NCR and Delhi. They also have their charging mechanism and they have sufficient spaces. They have developed their business model in such a way that during the night time they will be charging, and in a staggered way they will be running their vehicles and going to the charging places. So come. In case of the villages, we should not leave the villages. The tractors have been electrified. You may be knowing. Initiatives have been taken. And long back, the suggestion was mooted once by me that we should not ignore the tractors because they are the diesel guzzlers. And without addressing the tractors issue and de-dieselization of the tractors, our efforts of energy transition will remain incomplete. So those are also in place, and there, whatsoever the community facilities are there, they could be parked there. As and when the electricity needs are there, it could be done. Thing will be that developing a proper business model and making the awareness among the users that how they can support the grid, how the DISCOM could be benefited, and how the DISCOM can offer the benefits to all the users. So that's all from my side, and I do not know what the data center will think of. So
Thanks.
mobile data centers will be in future, and maybe on large truck loads and all those things, they can have something. It's a futuristic thinking. Of course, right now they have a lot of cooling requirement, dual power supply, and in data center, one limitation come that they all want to be very near to the shore, where the communication, subsea, intercontinental communication cable is there. So what that limitation will come, how the grid will reach to each and every data center needs, which is having a load of 300 megawatt, 400 megawatt, and like that. Ramakrishna ji is now in EV business, so he will not be facing this type of the much problem, but his teammates must be facing the problem how to meet their demand. And we in CA, of course, I just recently superannuated on 28th of February. So we also feel the pinch that how this 400 kV line and that much of the loads would be supplied, and that too with a very, very high degree of reliability. And as you move near to the shore, a lot of this chances of cyclones and other natural phenomena are likely to happen. Major thing, even in the normal circumstances, being the salt-laden corrosive atmosphere. So these are all the concerns which should be seen in an integrated manner. And I think I should take your permission now to stop it. And I'll be listening. I am on the online.
Thank you, Rajputji, for giving the broader perspective of technical aspect. Is also touching upon the supply chain sustainability and giving broader perspective of different dimensions into this space. So thank you for your inputs. I think we are running out of time. We are overshooting the time that we had planned. I would now like to ask the final question, where I would like to seek the opinion from the members. Maybe again starting with Mr. Bjorn. As we mentioned earlier also, that business viability is very important aspect of this economic viability of this new technology or new application that we are talking of V2G. So what, in your opinion, do you think in terms of the economic viability or the business model or the use cases that you think actually can make this V2G economically viable as we move forward? Beyond.
Well, there's a lot of initiative underway, for example, in California, to come up with new tariffs. If the grid operators want to take advantage of this technology, V2G technology, they have to create a business environment where somebody will be induced to make products and to serve that market. So it's not a static process. It's something that is ongoing and developing. There are initiatives from the interest organization, for example, 𝐕𝐞𝐡𝐢𝐜𝐴 Integration Council in Berkeley, which is an interest organization that are lobbying or influencing the regulators. And they are basically coming up with, for example, there has to be symmetry. So the energy that you get from the grid and the energy you supply back to the grid, if you're doing V2G services, have to be symmetrical. That means it has to be net metering. That's just one example. There was another example where we have something called ELPR, which is basically emergency load reduction in case the grid is in big troubles. So we have $2 per kilowatt hour, for example, which is it's not a lot of times per year and so forth. But I guess I'm saying there has to be some kind of innovation on the grid operator side, on the regulator side, I should say, in order to make it possible. There are new technologies and new concepts like transactive energy, where you're moving very much towards real-time price signals. It's still in its infancy. We have a number of trials going on in California. The same goes for the European sector, where there's a lot of focus now on how do we make it attractive. First of all, we have to be interoperable to save, to cut down the cost. And then we have to scale the technology. So we need to have some kind of plug and play, just like we had with the mobile industry. But that's not enough. That's going to lower the costs of V2G solution. But there has to be an income side, or there has to be a saving side. So the same thing is going on in Europe. How do we come up with more innovative tariffs? And whether they're real-time signals and so forth. There's another things going on, like, for example, how can you use it for energy trading, like intraday trading? If you make the trading windows shorter and shorter, you can make more arbitrage and so forth. So it's a process that's ongoing. Now, the last thing I want to mention is that where do we start? There's a lot of car companies that now have that have bidirectional capabilities. That means they can do vehicle to load, like a battery. That's very low-hanging fruit. If you want to lit up your Christmas tree or whatever you want to do, that's very simple. Then the next thing in California or in the United States is vehicle to home in case of emergency response. If the grid goes down, which it does a lot over here, that may not be the case in other regions. So they may be going first to vehicle to home and then as a segue to vehicle to grid. But the real advantage that the society and the grid will have is vehicle to grid. And I think it's a process that if I could advise in India, that we need an interest organization that can really take the results from what you're doing, the GIL and other trials, take those results and then somehow influence the regulatories. And whether you want to do that with other trials first to gain experience, fine. But that's basically my take at it, that we need some kind of innovation on the regulation side in order to make V2G really feasible and scale it and take full advantage of it. And time is short, because 2030, we're going to have 8 million cars in California. And so we're just in sandbox right now. We're just playing around. But if we don't come up with something where we can take advantage of that cheap battery capacity, maybe not for long-term storage, but certainly for 4+ hours storage, I think that we have a problem. I see it positively because there's so many things happening. And for example, now GIL and IIT Mumbai being part of Task 53, that would provide them excellent opportunities to be part of an international consortium that paves the way so you don't have to carry the cost and the resources, and then somehow apply those results locally to India. So that's my very short answer to that question.
Thanks, Bjorn. Very interesting perspective. Without further ado, I would request Mr. Ramakrishna to provide your thoughts on this particular aspect of potential use cases and viability in terms of this V2G.
Yeah, so I am very hopeful and very optimistic on this particular aspect. And if you see the kind of work is being done globally, and Mr. Bejon also, given a lot of data and input. So this is going to be household phenomena in coming days, along with the RE integration, rooftop solar integration, and this can make this can impact the overall power sector in India, not only by reducing the AT&C losses, but can also reduce substantially the overall network and grid upgradation cost. So if we are having the generation at the load side where we are charging the EV, we also have the rooftop solar. And Ministry of Power has also recommended to have that, rooftop integrated EV charging stations. So I'm very much optimistic, and I think it's a huge. Even if you see around 2 lakh four-wheelers in India, can add around how much? Even average 30-40 kilowatt of a load, 40 lakh, that is 4 crore, 4,000 megawatt load. So it is a huge potential without any cost is coming to the only thing we need to follow up with the regulator, do policy advocacy, so that the regulator come up with the suitable recommendation which is beneficial to the DISCOM, beneficial to the customer, and beneficial to the EV owner. Thank you.
Thanks, Mr. Ramakrishnan ji, for providing your inputs on this. Final remarks, maybe 1 minute remark, Mr. Rajput ji, from your side.
So 1 minute, less than 1 minute rather say, I would say in one sentence that it is basically a resource optimization technique, and whatever best we can do and whatever we can gain out of it and whatever benefit we can offer to the public, that is the overall gist of this particular whole exercise. And one more thing is that the government sector as well as the public and the individual sector, they should not be treated in a different way, because they have also invested. It is their money. And whatsoever in this public transport system like the buses or road transport buses we have done, it is also basically the public money. It's not that something it is coming from within. Rather, the individual owner should be given a better treatment and a better priority, because he has invested his own, and maybe he has taken also a risk to participate in our programs and in our endeavor to meet the needs of energy transition and of the demand side management. So the perspective should change. There is a set of mind among the people, particularly in some sections of the society, that if a private owner is there, that he is only coming for a high benefit business and may not be doing the service. He should also be treated that he is also providing services. Example is like, say, earlier it was Air India, say government run. Now it has been taken over by Tata, and now no government airlines is running. So we are all availing the services. Earlier we were availing of the government. Now we are availing of the private. So a distinction should disappear. All should be treated in a uniform way and in a proper way, in a legalized way and streamlined fashion. And whosoever are the policymaker and whatsoever the policy we make, they should not create unnecessary hassles and hurdle. They should rather streamline the functionality. Thank you.
Thank you, Rajput ji, for providing the the bigger picture insights and outlook of this particular development that is happening in the country. I think we have overshoot with time, but I am sure that there's a lot of interesting discussion that happened around this important topic, with a lot of insights from the different perspectives brought in by the expert panel members, and I'm sure the audience definitely benefited from this panel discussion and will continue benefiting in the future also, because this is going to be made public for the benefit of the public in general. And as we understood, if I want to summarize in one statement, that panel discussion, there is a potential, there is a lot of potential in this EV ecosystem for vehicle to grid application. It is it's only a matter of how we channelize these resources, how we make enabling environment to make better use of this electric vehicle battery that is out there, going to be quite a bit in the system. And then how we have the enabling interventions in terms of policy, technical, and other social aspects that are required for seamless adoption of V2G. So with this smart charging and all that, V2G, a lot of communication is involved. A lot of sophisticated communication also is part of it. So therefore, cybersecurity becomes one of the critical aspects, and then safety, as you mentioned it, islanding, anti-islanding, all those aspects are very, very
Yes.
critical, very insightful. So
Yes.
certainly, so thanks for giving those inputs, Mr. Rajputji. With this, I would like to sincerely thank all the panel members for sparing their time from their busy schedule and enlightening this audience with the panel discussion and providing your insights and constructive suggestions as we move forward in the journey together. Thank you so much for your time. Thank you.
Thank
Over
you,
to you.
Professor Jacket.
Thank you.
Thank you, Professor Jam.
Thank
Thank
you.
you, Mr. Rajput.
Thank you. Have a nice
Thank you,
day. Bye.
Okay, sir. Thank you. Good day.
Thank you. Thank you.
Thank you everyone. Yeah.